question of CSIR-NET, and in this question we use the concept of Jensen inequality. This inequality states that if g is a continuous and convex function on interval I or I naught, that is set of interior point of I, and x is a random variable whose value in I with probability 1, then expectation of gx greater than equals to g of expectation of s, provided that expectation of g of x exists. Now in this question we have given that x be a non-negative random variable. This statement implies that value of x greater than equals to 0, and in this case, that is for this question, I is equals to 0 to infinity and I naught equals to 0 comma infinity. Now we are in this question we have given that expectation of x is equals to 1 and asked which of the following quantity is necessarily greater than or equals to 1. Now we discuss options one by one. Now come to option first, that is expectation of x4 greater than equals to 1, and we have to check this true or false. For this we let g of x is equals to x4 and g dash x equals to 4x cube, g double dash x is equals to 12x square. Now this implies that g double prime x is equals to greater than equals to 0 on I or I naught. This implies that g is a convex function on I and continuous on I. So we can use Jensen inequality. This implies that expectation of g of x greater than equals to g of expectation of x. As expectation of x is equals to 1 and g of x is equals to x4. This implies that expectation of x4 greater than equals to g of 1, because g of x is equals to x4. This implies that g of 1 is equals to 1, and this implies that expectation of x4 greater than equals to 1 implies our first option is true. Now firstly come to option 4. In this question we have to check expectation of 1 upon x greater than equals to 1 true or false. For this, let g of x is equals to 1 upon x and g prime x is equals to minus 1 upon x square and g double prime x is equals to 2 upon x cube. This implies that g double prime x greater than 0 on I naught. This implies that g is convex function on I naught and continuous on I naught. So we can use Jensen inequality, and according to this inequality, this implies that expectation of g of x greater than equals to g of expectation of x. Now g of x is equals to 1 upon x, and we have given that expectation of x is equals to 1 in this question. So this implies that expectation of 1 upon x greater than equals to g of 1. Now g of x is equals to 1 upon x, so g of 1 is equals to 1. This implies that expectation of 1 upon x greater than equals to 1. So our option 4 is also true. Now come to option 3, that is C. In this question we have to check expectation of square root of x greater than equals to 1, true or false. Now for this option, we let g of x is equals to root x and g dash x is equals to 1 upon 2 root x and g double prime x is equals to minus 1 upon 4 x 3 by 2. This is less than equals to 0 on I naught. This implies that g is a concave function on I naught and g is continuous function on I naught. So by using Jensen inequality for concave function, this implies that expectation of g of x less than equals to g of expectation of x. This implies that expectation of root x less than equals to g of 1, as g of x is equals to root x, so g of 1 equals to 1. This implies that expectation of root x less than equals to 1, but we want greater than equals to 1, so in general this option false. Now come to option 2, that is of option B. In this option, expectation of cos x whole power 2, expectation of sin x whole power 2 greater than equals to 1, we have to find true or false for this option. Now for this option, as we know that cos square x plus sin square x is equals to 1 for every x greater than equals to 0. This implies that expectation of cos square x plus sin square x equals to expectation of 1, as we know that expectation of constant is constant. Now this implies that expectation of sin square x plus cos square x equals to 1. Now as we know that on I, that is I is equals to 0 to infinity, sin x and cos x both are convex and concave nature, so we let J subset of I such that sin x and cos x both are concave. So this implies that expectation of cos x less than equals to cos of expectation of x and expectation of sin x less than equals to sin of expectation of x, sec 1 sec 2. Now from 1, expectation of cos x less than equals to cos of 1, and from 2, expectation of sin x less than equals to sin of 1. Now this implies that expectation of cos x square less than equals to cos square 1, and this implies that expectation of sin x power 2 less than equals to Sine square 1, say 3, say 4. From 3 and 4, we have expectation of cos x power 2 plus expectation of sin x whole power 2 less than equals to cos square 1 plus sin square 1. Uh, this this quantity equals to 1. This implies that expectation of cos x whole square plus expectation of sin x whole square less than 1. But we want this inequality reverse. So in general, this option false. So come two options. This option correct, this incorrect, and this correct.